All right, we'll start. A couple questions from these, right? I had you write down engineering questions. So I'll answer a couple of them. Huh? Heck no. Unless you want me to call your name out. Yeah, well, you can always email me for more details. All right, slowly going through them over the term. Maybe we'll get to all of them, maybe not. But first one is, what's the difference between architectural engineer and a civil engineer? So I'm going to guess that question is, what's the difference between an architect and an engineer? Right, let me answer that one first and then I'll build on it. So architects design the use of space. Okay, so if we're going to build a school and the school is going to have 20 classrooms, right? But then it also needs to have maybe, I don't know, 4 bathrooms, 2 male, 2 female, right? Maybe it needs a bookstore, maybe it needs a library, maybe it needs all these things. Architect is going to lay out what the classrooms look like and how they're used. So they might come up with this configuration: tables in the middle, computers on the outside. That would be an architect that would design that, right? A door coming in, a door going out to a lab, right? Bathrooms around the corner, relatively close, the library up there. How you get to those spaces and how people move and use the space, that's an architect. Has nothing to do with the structure. The architect then takes that plan, hands it off to an engineer, and then an engineer designs the building. Figures out like, hey, we need bricks. I don't know why we need bricks, but I guess we need bricks for this building. We want to build it with bricks, so it's super strong. We need these concrete columns out here, and they need to be that big for this thing to stand up. That's what the engineer does. Both of those people kind of need to know each other's job, but not all the details, right? So an architect needs to understand structures good enough to where they don't design something impossible to build, right? So they do have to have some knowledge of like construction techniques, but not much. Like I've been given drawings by an architect and then wondered like, what were you thinking? It's not even possible that we can do that. That span is too big, or that span is too high, or that span is inappropriate, right? So not all architects are fully in tune with all industries. A lot of times architects are going to have their niche, like residential or commercial or small commercial or big commercial, right? But beyond that, they don't have the expertise. They need an engineer to produce the drawings and the specifications of the structure. Does that make sense? Architects are not engineers. Engineers are not architects. Okay. Now, the real question was architectural engineering. Well, that didn't exist for a long time. It was just architecture. Like if you want architecture in the state of Oregon, anybody know where you go? What school? No, actually they do have architecture down there. CSU does. U of O, yep. Big time architecture program, big time, right? If you wanted engineering, it wasn't the U of O, they don't offer engineering, right? It's Oregon State or Portland State or some of the other small schools. Now, there is architectural engineering construction degree at Oregon State. Oregon State has blended the architecture program and the engineering program to come up with that architectural engineer. Fascinating. It is an architect that has a bunch of engineering courses, right? They're not a structural engineer, but they have much better knowledge base. So there you go. That's the answer to that question. Any questions on that? That was a good question. They're an engineer that knows some architecture. Architectural engineer. Yeah, it is different. It's a new breed. It's a better breed because they can do both. It's an engineering degree that has a bunch of architecture into it. So just a perfect example of why engineers are not architects. I designed my own home. I built my own home, but I'm not an architect. So I do not have things like large closets because I don't really give a crap about closets, but that's a mistake, right? If we go to sell our home, people are going to walk in and go, what's with the tiny closets, right? There's no walk-in closet, really? Like, no, we wouldn't waste space on that. We have no coat closet at our front door. So when we do have people over, guests, and they want to take their coat off, we're like, yeah, we never thought of that. So just throw it on the couch or something, right? We have no shoe area at our front door. So when we take shoes off, it's like, there's 5 of us in my house and there's like shoes everywhere because there's really nowhere to put your shoes. So that's an architect that figures out all those details, right? There's things like the kitchen triangle. That's the flow in the kitchen. That's like where the dishwasher is, where the sink is, where the stove is, and where the fridge is. If you muck that up, 2 people literally cannot function in a kitchen. Ours is mucked up, like it's chaos in our kitchen. So that's an engineer design. It's a nice home. It's like the structure is super cool. I have these giant beams that large spans, right? It's really a nice place when people walk in until they realize like it's missing some key components that it's supposed to have. So that's the difference between an architect and an engineer. All right, let's do one more quickly. What would an entry-level tech be responsible for? So 2-year degree, entry level, most of the time you're going to run AutoCAD or SolidWorks. You're going to be responsible for drawings, right? A lot of times that is an as-built, which means we've built this thing. It's really cool. We're selling it to people, but we have no drawings. And that actually happens a lot at smaller companies, a lot. So then they hire a tech to come in and like start to document what's going on in the facility, which means you're drawing things that are already built. That's why they're called as-built. Yeah. So, yep. As a 2-year degree. Yeah, probably at Boeing, since it's so huge, you're going to be in a very specific job, probably in some kind of a reliability or testing function. In other words, they build things, right? They build a lot of small parts and then they build some giant parts. But since it's aviation, those parts have to be tested about every so many parts. Depends on the run. Like if it's a run of 100, you'd probably have to test parts every 3rd part type of thing. So that's got to happen so they know there's consistency in the manufacture of that part. Aviation's really tight. Like things cannot be wrong. Things have to be right. Well, so you get on a plane and it flies somewhere and you get off a plane and it's not too much drama, right? That's a good thing. Excellent. Any other questions before I give up on this? No, we're good. All right. Well, thanks for coming, y'all. Thought I was going to be here all by myself there for a bit. Well, there was 6 of us at the 9 o'clock time. So that was scary. All right. Blackboard, just a reminder, there are things to submit in Blackboard and they're just going to keep coming. Today, you have something to submit in Blackboard. So almost every day there's a lecture. I'm going to follow it up with making you do something. Don't miss those things. They show up as zeros and they impact your grade, right? So just keep track of stuff, get a notebook going or your phone and reminders, something. Come up with a system, okay? So here is my grades. So I'm not showing a student grade, I'm showing my grades. So I keep these going and just have fun with them, right? In the end, I will get an A in this class, just so you know. But this is what it looks like when you go into the grades. If you haven't been there, you should go in there. The grades show up here. If there's nothing like this one, that just means I have not graded anything. Doesn't mean you didn't do it. You don't have a 0, so that's good. Just means I haven't done my part, okay? If a 0 shows up, that means you didn't do your part and you got a 0 out of 10 or 20 or 30 or whatever that's worth, right? And there's a comment. You should read the comment because the comment could say, hey, you missed this. If you submit it in a week, you can get the points for it, right? And that's just my way of making sure you're going in and checking this. Sometimes you'll see 10 out of 10 and there'll be a comment and the comment will say, nice job, or something like that, right? So you click on the comment to see it. This one says, no posting, question mark. Just means you didn't do it, right? So this one clearly 10 out of 10, 10 out of 10, good, no comments. And then this one just not graded yet. Cool. All right. And then there is a grade to date running. So if pandemic number 2 happens and we all just disappear and I have to give you a grade, that's what it's going to be, because that's the current grade. Okay. So track it, keep track of it. If something turns out to be a 0 that you did, email me, like, boom. Sometimes I put in, like, if it's worth 40, I'll give you 10 out of 40. That means you didn't do something, but that's a little dramatic. I took 30 points away. That's because I want you to see it and see my comment and then do whatever you didn't do, right? So I'm looking for a response there. If you get a 0, flat out 0, and you actually submitted something, then I'm definitely looking for a response. Okay, so get in tune with Blackboard. Some of you missed some of these things, which at this point impacted you a lot. It won't be a lot in the end because we're going to accumulate points as we go through the term, right? But just stay in tune with it. So in the end of the term, you don't come to me and say, I didn't know I was getting a B in this class. I really need an A, right? I'm like, all term I've been saying, check Blackboard, right? You all know what you're getting because you're checking it. All right, enough of that. And then again, stay in tune with the calendar. Oh, sorry about that. Still don't know why it does that. All right, this is our class. So today we're gonna have a lecture, lecture, and then you have a posting to do here, and it's due EOD. What's that mean? End of day. It's due today. Okay, so, huh? Yeah, that is the grid story, and we're gonna talk about grid. And then on Thursday, you can see we have online lecture. You might have something to do in that online lecture. So you got to find a time Thursday to sit down with your headphones and listen to me. Yeah. Okay. Gonna have a quiz on Thursday. So yeah, that's wrong. We're gonna have a quiz on Friday. I don't know what that's doing there. I'll get rid of that. And then we're gonna have a lab. And in lab, you have to do what? You have to bring 2 square feet of cardboard Thursday. 2 square feet of cardboard per person, right? Or Thursday, that can be a cereal box. Take a cereal box, that's cardboard, open it up flat. It's about 2 square feet. I'm probably not going to measure your cardboard, right? So everyone should have a cereal box. If you don't, your neighbor has a cereal box, go get their cereal box. Or hit the dumpster and recycle bin. Yeah. Or one piece? Good question. Combined is fine. Doesn't have to be a full 2 square feet. Yep, you're going to cut it up anyway. So. Questions? We're good? All right. Calendar, keep track of it. Grade, keep track of it. Homepage, keep track of it. All right, let's go away from there. New share, lecture, share. Slideshow from the beginning. Perfect. All right. So I'm going to start with a real brief kind of introduction to me and what I did when I graduated. So part of this class is trying to understand, what are the options out of the different disciplines. So rather than kind of go over, I will go over mechanical engineering at some point kind of in detail, but as a mechanical engineer, you are going to be in the broadest field possible. That's one of the attractive features of mechanical. Mechanical can be in any facility that manufactures anything. So any company out there that creates something that is either selling it or using it is going to have mechanicals on board. So that's kind of endless products. So you can think of the transportation industry if you want. That's a common one that mechanicals go into. And that's, cars, trucks, buses, planes, all of those get manufactured, right? Somebody builds those things and we buy them. We buy a car or we buy a plane ticket and get on a plane, or we buy a train ticket and we get on a train. The transportation industry hires a bunch of mechanicals. Less in our area because we're not the transportation hub manufacturing of the world. But just north, Seattle is, they make planes. And we do have a Portland branch of Boeing that makes plane parts, right? We do have Freightliner and a few other large truck manufacturers here in Portland. So we have a lot of transportation. We have TriMet. They take a lot of mechanicals because there's a lot of work to be done on the system of moving the electric buses around the town, right? So Max Light Rail, that's all transportation. That's all mechanical engineering. You'd go to work for that kind of a company, right? And then just think about all the other products that get manufactured. You know, we have some semiconductor industry in Oregon, right? That's being manufactured. A chip is made by a manufacturing facility, microchip on semiconductor. All of those companies hire mechanicals because there are a bunch of mechanical processes in the manufacture of a microchip, right? So other companies like construction companies, if they're big, will hire mechanicals. Smaller ones aren't going to do that, right? They're just trying to make their way. But large ones are going to hire mechanicals because large companies are going to own their own equipment. And if you own your own equipment, then you want that equipment to do special things at times. So I went to work for Kiewit Pacific, right? Large construction company. Think big projects. They have a structural division, which builds large buildings and large structures like bridges, tunnels, those kind of things. They also have an earth moving division, which is involved in moving the ground, right? So if you need a landfill in a big city like the city of Riverside, California, which is where I went to work for my first job, they needed a landfill, right? So they hire a company like Kiewit to dig a big hole. That's actually not how they do it in California. Anyone know how they do landfills in California? It's so sad. They take the most beautiful valley between two mountains, like this most gorgeous mountain rolling, you know, deserty type, gorgeous terrain, blue sky, California, and they build a land dam. And they literally dam up the valley, and then they take all your trash and just dump it in the valley. So sad, but less digging, right? You don't have to dig a hole if you just take two mountains and like build a dam across it and fill it up. So that's what we did. Their philosophy is no matter who you are, if you're an accountant or if you're a mechanical engineer or if you're a civil engineer, the first thing you do for that company is you go on a job and you learn everything about how that job runs. So I didn't really have a job when I went to that job. I was just like the guy that was supposed to learn everything. So I did everything from run scrapers. We did some belly sliding of scrape. Anyone know what a scraper is? Large piece of equipment that has a big bowl in the middle. I don't think I have any pictures of scrapers. No, I don't have any pictures of scrapers. They have a big, like a dump truck bowl in the middle. They're super heavy and they're very, very, very large. And they drive along and they can lower their bowl and there's a big blade and the earth that it scoops just goes into the bowl. So they can load themselves just by driving. Drop that big blade. Think of a grader or a snowplow that's pushing snow. So instead of pushing it, it just pulls it into its belly, right? And then when it's full, it just lifts it up. Now it has a load of dirt. So you can move a bunch of dirt that way, as long as the dirt's just the right dirt. It can't be too hard, can't be too soft, but they're really good at belly sliding, like a beaver slide. So they come down a hill, going downhill, they have a lot more force. They can just lower the bowl, fill that bowl, just boils over with soil and then lift it up and then they go down and take it somewhere and haul it. So they can like carve these canyons out really easy. So I did some belly sliding with a scraper. It was super scary because it was super steep. And if you lifted the bowl too early, you just start like whooping. And we rolled a couple scrapers on that job. Not me, but we rolled a couple scrapers on that job. Almost killed people. So anyway, that's what I did. I went out and learned. So I spent like 2 months with the project engineer and learning all the scheduling and the budgeting and all the nightmare of running a big project. And then I hung out with the mechanics too for like 2 months. We were working on equipment. So the mechanic's job is to keep that equipment running. If that equipment's not running, we're losing money big time. So an enormous job. When I got back to Portland after 2 years down there, which was 2 years too long, I started designing equipment for those people. That's what they hired me for. It's like, okay, our mechanics trailers suck. Our mechanics hate them, and we need something that functions better. So my very first job was to design mechanics trailer for the mechanics on the job. And I knew what their job was because I had been out there for 2 months, or 2 months with them, but I've been out there for 2 years, right? So it was super easy. Like, they were building success into me. I made some mistakes, but it was pretty easy to do. So we designed and built these trailers. I didn't build it. I just did the paperwork, design work, right? How are we going to put the equipment in the trailer that they need? How's the power supply going to work? You know, how are we going to get plugins in the right spots? How are we going to get all the parts and pieces that they want and stored? And also it had to be legal hauled down the road. So you can't like overload the trailer. You can't put too much weight in it. And you can't unbalance the trailer. Trailer's got to be balanced to go down the road. So I was like statics, man. And I love statics when I took that class. So you'll take statics. It's a study of forces and equilibrium. It's how to put things in balance, right? It was golden. It was awesome. So that was my first job. Then I became the conveyor guy. So Kiewit's so big that they don't buy rock. They buy land and make rock. Like, that's a big company, right? So they buy a little mountain somewhere, go through all the logistics of getting approval to dig it up and make rock. And then they make their own rock with a rock crusher. That's a rock crusher where you put big rock in. This gets a hopper on it. Put big rock in, it pummels it into small rock, and then it sorts it into small, medium, and large rock, right? So I'll talk about that in a second. Oh, where am I going here? Back to this. So they needed conveyors, right? So that was my first job. That was really kind of engineering. These are, I'm going to guess that these are 80-foot conveyors. And you'll see that there, you can't really see, I guess, but this is one conveyor, that the top and bottom, and it's pinned right here. So it'll essentially just unfold into its full 80 feet. It's got to be at a slope, so it has to have some kind of structure to hold it up, some kind of legs to do that. It's got to carry the weight of the rock. So I had a ton, I didn't know anything about conveyors. Like, oh, really? I'm going to design a conveyor. I have no idea what's even how to start. So that was a learning curve, right? But that's why you go to school, because you learn how to solve problems and you ask questions and do some research and figure it out. Sizing the motors was tricky because they're all different widths. Sometimes they want a 40-inch conveyor. Sometimes they want a 20-inch wide conveyor. You know, 40 inch is going to take a lot more rock than a 20-inch, right? So you have to come up with your loads. You have to come up with your idlers and how often these idlers need to be spaced. You have to come up with your motor because you got to drive it at some slope. That's a lot of load to carry up and dump, right? And you really don't want it to fold up when it works. You don't want it to fail, but you don't want it to be so heavy you can't haul it down the road. So yeah, it's a bit of a game. So I think my first conveyor I designed took me like 2 months. And they're like, what the hell are you doing? We need this done. I'm like, this is hard. I can't figure it out. I'm scared, all those kind of things. And then the second one, of course, was like a 1 month instead of 2 months, right? And then I realized they're going to make me do this like over and over and over because I'm now the conveyor guy. So I built myself a spreadsheet and I put all of my calculations, about 8 pages of calculations, and all of the questions that I had to ask myself in each design, I put into Excel as input sections. So when I got that, that took another 2 months to build the stupid spreadsheet, but I kind of did that on the side. Nobody knew I was doing that. When I got it done though, they could ask me for a conveyor and I could give them all the design specifications for the conveyor in about a day. And I think I told them it was a week. So gave myself a little cushion there, but I could do it super fast. And then pretty soon I just started giving the stupid spreadsheet away so somebody else could do conveyors because I was really sick of it. Yeah. So I would put input parameters like the length of the conveyor that they needed, the width of the conveyor that they needed, the angle that the conveyor is going to operate on, These are the kinds of conveyors I designed. This is the only ones that I was responsible for, were these long transport conveyors that would move the rock away from the cone crusher. Right, so I'm gonna use the same spans for each, pretty much. I'm gonna use the same C channel for the rails, pretty much for each. The things that change are the idlers and the idler location, the motor size, the leg parameters, like where you put the legs. If it's a 60-foot conveyor, the legs go in a different spot than if it's a 80-foot conveyor or a 40-foot conveyor. So there weren't that many parameters that changed. So once I put that in, it would just spit out my spacings and everything. And then I had drawings that I had made. By that time I was in CAD and I could just pull them over and modify them, produce it pretty fast. So anything you do repetitively over and over and over, once you get on the job, think about like a way to make that more efficient, right? All right. I think my next job was, I don't know if it was the next one, but it was another one. This is a screen. So it takes, again, takes big rock, not really big rock, but it does take crushed rock. And then it sorts it into small, medium, and large. So you have different conveyors that are going to come off of this thing. And I didn't design the screen. We just buy those, right, from the screen company. But they needed all the OSHA safety features put on it because it has to operate safely on the job site. So all the hand railings was my job. And then the front leg position, how to get that up and down, obviously, and tucked away for transport because it is a legal haul. It's got to be legal haul on the road. But once it gets on site, they wanted it to pretty quickly set up. So they'd take a big crane, lift it up, and then they'd flip the legs into place. And then, you know, how are those legs going to work type of thing. Yeah.
How do you source a part for something that size, right? Like you design it like.
Oh, good question. Like this leg?
Yeah.
Yeah. So where I worked, I wish I had pictures of where I worked. This is where I worked. And you can kind of see the facility here, right? So big facility. I had like 6-day fabricators working in that facility, but we were often running 3 shifts. So we'd run 6 fabricators, you know, 3 shifts a day. So 18 fabricators, probably another 4 or 5 hydraulic specialists and electrical specialists.
Like pretty soon after you.
Oh, I saw it as I was drawing it. Like I had a window like that looked straight into the facility. And they wouldn't go to my door. They just come to the window and they'd go like this. Yeah. Yeah. So as I designed, they were fabricated. Yeah. Super fun.
Yeah.
Super fun. And a lot of money. Like we could just spend money like crazy. So yeah. So we were like direct dial to the steel folks, right? When I would size something, then I would order it. Actually, I had a purchasing guy. So he was right next to me, and then he would order it. We'd get the steel in, they'd start cutting it up and fabricating. Yeah, it was super fun. It was stressful though, super stressful. So then I got the trucks. So no, didn't design the truck. We just buy the truck. No bed, right? So we just buy the truck, no bed, and then I designed the bed. So these were super tricky, very tricky. These are all tanks. Right, 1, 2, 3 tanks, and then a little mechanics thing, and then the other side, one tank here, another tank here. So different fluids that the lubrication, they call them oilers, and just they're people just covered in oil, but they're called oilers, and they lubricate all the equipment. So like on the land, I'm going to just talk forever. Like on the landfill job, we probably had 40 pieces of equipment. Big pieces of equipment. And that equipment has to be serviced every so many hours. So there's always equipment that's got to be serviced. And we were running 2 shifts, so it's only down for a few hours. And the oiler has to get to it, lubricate it, everything, and then move on to the next one. So they needed a very mobile lubrication system. That's what these things are. So again, it's got to be working well for them and efficient. So we had to design it working with the oiler folks. So we flew some of them, put them up in a hotel, let them do whatever they want at night, and then they come to work and work with me to set up a good truck, right? So that was super fun. Very complicated pumping systems, complicated hydraulics, because these reels are going to these tanks, With it all full, again, it had to be legal haul, so. You can design this all you want. It looks good on my design, looks good on paper. And then they start putting things on the truck and things don't fit in the right spot. And then they want to move a pump over to here, that's fine. Then they need to move a tank a couple inches. I'm like, that's not fine. We cannot do that. Because when the thing gets done, it's gonna roll across the street to interstate heavy haul, and they're gonna scale it, loaded. And if it's not legal haul, that's on me. Yeah, then that truck's down. Or we have to run it with half tank, you know, like, oh my God, talk about losing years of your life, huh? Yeah, they want it, once it's done, they want to put it to work, and the only way it's gonna get to work is to drive it down the highway. And if it doesn't legal haul in Oregon, then I'm in trouble. It might be going to California or Alaska or Hawaii, but to get from my facility to the port, it's gotta go legal haul. Like, and we're not gonna try and get away with that, because if we get caught, we're gonna be super busted. Not gonna get, we're not doing that, because if we get caught, it's gonna be a massive fine, because they know how much Kiewit makes, and they're gonna fine appropriately. These were okay, because we could empty the tanks if we screwed it up. And we did have to empty a few tanks now and then to get it to the port. But that's all right. Once it gets on the job, a lot of times these stay on the job and they don't legal haul, so they'll work fine. So these were less stressful. This one was a nightmare to get that cone crusher to go legal haul to a barge. That was brutal. And it barely made it. Here it is legal hauling, heading for the barge. I was following it. It's going like this because it was overweight. It was super close on the axles, close enough that we went for it, but I didn't have much clearance here. And these things are so heavy. Like that cone crusher is going to take, car-sized rock and it's going to crush it up. So it's massive. Yeah, well, they're supposed to go not over 40, and I think he's doing like 60 right here. Typical truckers, like, we gotta go. I'm like flashing my lights, stop it. This is when it left after it got weighed and passed the weight. This was something we had to add after we got halfway through the project. I was like, there's no way. There's no way. No way. We're gonna get 2 axles. So we had to add this on the back. Yeah, super stressful. And it was only ever supposed to go to Hawaii. So it made it to the barge, got on the barge, went to Hawaii, legal hauled where it needed to go, set up, ran 4 or 5 jobs, like 10 years. Then they moved it back to California and they tried to go somewhere into California with it, and it like busted in half, halfway down, dug up the highway when it busted in half. Didn't kill anybody, but that wasn't on me because I put a plaque on it right here. And I put a plaque on the other side that said, 1 legal haul, just to the port, just to Hawaii, does not get moved. And that was the agreement. So they broke that rule many times. Yeah, a lot of fun stuff. That's a culvert delivery system. So we did the big tunnel job in Seattle where we literally bored a tunnel under Seattle. So no, this is for moving, I think it was 12-foot diameter concrete culverts. So these are giant, like taller than this room, concrete culverts. And what they did was the tunneling division tunneled, built this tunnel, and then they're like, how are we gonna get the culvert in there? Honestly, that's what it felt like to us. Like, this is a total afterthought. Like, you had no idea how you're gonna actually get it in there. So then we have a tunnel, which there's not a lot of room in this tunnel to get this culvert in. So they said, well, just make us a dolly, like a little thing that we can just drive it in there. Like, okay.
I love how you did it like this. Like,
We can, it's a joystick. Yeah, you don't see the joy. Oh, maybe you do see it. That's a joystick right there. Yeah, you see it? Yeah. So we took a excavator, a 235 it's a big backhoe, right? That digs dirt. And we just like took it apart. So we'll use that excavator. We'll use those tracks. We pulled it all apart. The guy's name was Gary. He was just a riot. It's a hydraulics guy. He's like, we can do this, man. We can just put pumps on here and like, let's do it, Gary. So I didn't really do a lot. I did the design work on this, and then I found the folks to roll this for us. That was quite difficult. And I did this design work just to carry the load. The carriage was fine. It could carry the load easy. But then Gary, the hydraulics guy, was like, yeah, let's build a joystick system. So we did, and you could literally walk with it and just go, "Meow." It was super cool. And it went up and worked, and they took their culverts in and it finished the project. So the pipe dolly. I don't know where, I never know where anything goes after it does its job. Like it probably is at Gary's house and he plays with it. I don't know. All right. Last one. This was super fun. This is a backhoe, right? Those of you that don't know, a backhoe digs dirt. You sit in a little cab here. There's Gary again, sitting in the cab. He's got his coveralls on. I think he wears those 24/7. He's a great guy. But they needed a backhoe that dug off to the side. So backhoes typically just dig between the tracks. You can dig off to the side a little, but if you have to do that a lot, you can't track. Like you have to go backwards then, and then you're digging off to the side and the bucket's not in line with the ditch, and it really makes, it's not easy to do. Operators can kind of do it, but we had like 40 miles of ditch to dig next to a slope. So again, in California, here's the highway. Here's like some kind of slope, and they needed to dig this right here. So you couldn't really, you know, if you put the tracks between it, the track would be like here and here. These are the tracks, right? And then you know, it's just wasn't going to work like at all. It was going to destroy the bank that was there, the ditch. So they said, well, can't you just make a backhoe that takes off to the side? I'm like, no, can't do that. It's stupid. Yeah. No, we're digging in line this way. 40 miles. Here's the highway. Here's the slope to the right. And they need the ditch work here. Okay. So the tracks would have to sit here. But if you build an offset backhoe, then the tracks can just sit right here. Nice and flat, right? And you dig here. That makes sense? Yeah. Digging off to the side. That's what this is doing. So this is our offset boom that we built. So this was tricky because this is a big load and it's torquing this whole system, right? It just wants to fold up. So inside of this round section, I had a bunch of torsion drums. It's kind of think about it like an auger, a round system. And that was just to pick up the torque. And then this was just a stability, you know, building triangles. That's a good thing if you want stability. So this was just a stability strut over. And we took a boom. This is called a boom, this part. This is called the stick. We took a boom and literally cut it in half, right? And said, okay, we'll just move it over and build this cool structure. So then, I don't know who said, we could really screw up the carriage. Like this loading condition on this carriage is like that's not supposed to be like that because that's supposed to be more in line. So this was a brand new, looks like a 235. Yeah, it's kind of small. This is a brand new 235 Cat, and Kiewit, largest customer for Caterpillar is Kiewit. So we had a lot of power with them. But we did tell them, hey, we're doing this. And they said, no, you can't do that. So then my boss flipped out on them, and then they got in a big pissing match. And then Caterpillar voided the warranty on this piece of a machine, on this piece of equipment. And that really pissed my boss off. So he's like, screw them. Let's show them and let's get them. So we painted it green, which is Komatsu. If you don't know Komatsu, that's another big equipment company. Well, Kiewit only buys Caterpillars. We don't buy Komatsu because we get this great deal, right? So we painted it green and put it to work out on a highway on a Kiewit job. And it was about one day before Caterpillar said, what the, you bought a Komatsu? We're like, no, we just painted our Caterpillar that you voided the warranty green, and we put Komatsu stickers on it. Oh, it was so funny. They were so pissed, but they said, all right, you can have the warranty back if you paint it back to yellow. And we're like, okay. So then we taught it back and painted it yellow again and sent it back out. It was pretty fun. That was about a year. Yeah, because there was other parts of the project. And again, it was not supposed to go anywhere. Oh, so this was the test. I'm standing here. I'm like, okay, I'm gonna take a picture. Gary, just take a little scoop for the picture. That's what he did. I'm like, what the hell? Yeah, he's like boiled it, buried it, stuck it in the ground as far as he could. He's like, that worked pretty good, you know? All right, put it to work. Anyway, good. Kind of get a feel for it. Yeah, each company is different though. Like if I went to Boeing, it would have been a lot more boring of a slideshow because I would have been like the brake caliper specialist for 14 years. Because Boeing will get you in a spot, they'll get you productive, making money for them, and that's where you stay until you throw a fit. So, yeah. All right. I didn't get to grit much, but I'm going to do it real quick. Got 5 minutes. So take a breath. Yep. Where is grit? Well, that's all my other stuff. We'll go over that stuff some other time. All right. So quickly, I can kind of give you grit in just a couple minutes. What do you think it is? First of all, someone says grit, what's that? Like, and we're talking about people, like gritty people. Yeah. Determined. Excellent. What else? Anything else? Resilient. Yep. Those are good. Those are perfect. Yeah.
Literally, it's like roughness. I mean, like,
No, it's more of a gritty personality thing. Yeah, but it's the same kind of thing. It's so roughness, I think, would qualify as a grit characteristic. So I kind of got into grit like 8 years ago, meaning I started to study it. Like, what is this phenomenon of grit and what makes people gritty? Like, some of us like to go to a Blazer game or to a Timbers game. Those athletes are gritty. They are enormously persistent and they can come from any background, right? They can come from impoverished backgrounds. I have students that have horrible home lives and abusive conditions, yet they come here and they display grit. Like, how does that happen? Like, some folks have it, some folks don't. And what is it? So then when I started to study it, I was like, man, if I could teach grit, I wouldn't have to teach anything else. Like if I could teach you grit, which I can't, I can only expose you to grit. I can't teach it. There's no way. But if I could make you gritty, my job would be done. I wouldn't have to teach you anything else ever again. I would just show you stuff and you'd be like, I'm going to figure this crap out. Right. And you go away, you figure it out and you come back and teach me. That's what would happen. So we decided several years ago, we would at least expose you to grit throughout the curriculum, because if you display grit characteristics, your success rate just goes through the roof in life and engineering, right? And it's going to take grit to get through a 2-year program or a 4-year program. It's going to take that. So let's define it real quick. It's a little different than what you said because it involves long-term goals. So we can be gritty short-term, we can handle our car breaking down and having to walk 4 miles and to get help. And then the whole chaos of fixing our car and getting it back going, right? That's not long-term. That's kind of a short-term thing, right? So to display grit characteristics in true grit form, it takes long-term goals. So this says it's a better indicator of success and happiness than IQ or talent. In other words, grit is more important than talent and IQ. You can have talent and be lazy. You can be super smart and be lazy, right? But if you have grit, you can like overcome those other things. So, all right, some characteristics of it. Courage didn't come up, but that usually doesn't. You hit the big ones. You have to be willing to fail to have this thing called grit. So, and it's okay to fail. That's the other thing is you have to like, you don't want to fail, right? That's not something that we want to do, but it's okay to do that. And actually, for the full understanding and characteristic of grit, you have to fail. Failure's got to be part of the process. So in engineering, that could be a class, or it could be a quiz, or an exam, or just a homework problem that you just completely failed at, right? Grit says, okay, that's going to happen. What's our response to that? Like, I coach baseball. My interest area is when you strike out, what is your response to that? Like, did you learn something from that? Do you then analyze that and go, why did that happen? And then try and fix that problem? Or do you like throw your bat down and head to the dugout, all pissy, right? So grit would say, okay, we're gonna fail. Let's like learn from that and not do that again. All right. So it's long-term goals and it's endurance, those kind of things. I'm gonna cruise through this a little bit because there's some interesting parts here. Resilience, you guys got that. Optimism, confidence, creativity, all that's good. There is research on this. So if you're interested in grit and kind of grit characteristics, then you can look at the research on it. I was going to show you a video, but we ran out of term. Her name is Duckworth, and she's the leader in grit. This is what she does for a living, is she studies it. She's wrote a book about it. It's fascinating. So this is a good one. I'll post this up. You can watch it. Fascinating stuff. So this is an interesting one, excellence versus perfection. It says gritty people don't seek perfection. In other words, we're not trying to be perfect, but instead they strive for excellence. So big difference between those two, excellence and perfection. We're not going to be perfect. No, right? You can practice free throws all you want. You're never going to hit them all, but you can be excellent at it, type of thing. Same with engineering, same with mathematics, all of that. All right. So the thing you have to do for me is you have to think about these kind of things. Here's the pieces of grit. You have to have an area of interest to really display grit. You cannot be not interested in it. So engineering, you're interested in it. That should be a motivator for you to persevere and get through it, right? A passion is helpful. If you have no passion for it, then it's hard to display grit in that category. Okay. This is the 10,000 hours of deliberate practice. You might get that. 4 or 5 years of school, you're going to get a lot of hours of practicing homework problems and those kind of things, right? And then when you go to work to be a really excellent engineer, takes 10,000 hours type of thing. It's great to have a purpose beyond yourself. So if the reason you're doing something is monetary, that's not a purpose beyond yourself. That's just like, I'm doing it for me, man. I want to make a lot of money. That's why I'm going into engineering. That's going to work. So to be really good at it or to be really gritty, you have to have a purpose beyond yourself. So maybe the purpose is to solve big problems for the world or the public or big problems in transportation, right? Think about that when you write your little grit story. Like, think about these categories. Hope, you got to have hope for the future or failure is going to stop you, is what she says in her research. Like, if you don't have hope, like, okay, I failed that quiz, but if I have no hope of passing the course, then maybe I just stop, right? I don't display grit, but I say, okay, I drop it. I'll try it another time, which is legit at times. I get that. And then, of course, you've got to have failure and overcome failure. So grit stories, they're all over the place for students and people. Yeah. Think about these points, but just try to think about a time that you've been gritty, and you have been, you just haven't stopped and thought about it. Some of the grittiest stories I get from students are medical, and sometimes it's just a witness of somebody being gritty, right? I have a good friend who has brain cancer, right? Incredible, like this is year 4, and they're still like, they have a lot of these characteristics. I'm like, wow, I'm not sure I could be that gritty. So it could be like a medical thing. It could be just a situation that you persevered through, right? But you have it. It might not be long-term. The long-term is the really hard part. So long-term, okay, so it was a few months. That's fine. Still tell me the story, right? Maybe right now, engineering is going to be your grit story in the end. So it's in Blackboard, post it up. It's in the private area, which is the quiz and exam area. Nobody else can see your grit story, just me. Okay. And then, of course, don't share any story with me that you don't want me to know about. So make something up if you have to. Good. All right. That's it. See you all Thursday. Sorry I went over. Let me stop the recording.